Hello, everyone. Welcome back to CAD 101 Computer-Aided Drafting. In this unit, we're going to be talking about dimensioning. This goes along with Chapter 7 in your book. Make sure you're reading the right chapter. We do skip a few chapters along the way. From this point forward, though, we will be following them in numerical order. And as I said, this is about dimensioning. So what we're going to be creating is what's referred to as detailed drawings. So far, what we've done is orthographic projections. If you recall, orthographic projections is when you take a three-dimensional shape and you describe it using various views, usually the front, top, and right side views. But of course, you could use more views than that. Detailed drawing, on the other hand, takes that orthographic projection and then adds dimensions. So it tells you how big it is, where things are positioned, etc., and any other specification that's going to be needed to manufacture it. So it might be something about the finish, it might be something about something like radii of fillets and rounds, something like that. So additional notes you will find on a detailed drawing. Here's a pretty straightforward detailed drawing. It's of a small part with an angle off the top and a hole through it. You'll notice dimensions are placed very neatly on both the front view and the side view. Of course, the front view and the side view are aligned with each other, same height, etc. In terms of the dimensions themselves, they're spaced out evenly. They don't cross each other wherever possible, and they're designed to give you enough information to completely develop and build the part. So one of the questions about dimensioning is about the values, and we want the question is, should we dimension an object using the dimensions that we use to draw the object, right? So the dimensions that you use to actually create the object, do we need to use those again while doing dimensioning? And the answer is no. It turns out that the dimensions that you need to draw the part may be a little bit different than the dimensions you need to actually manufacture it. So this is kind of important when the book sets up a drawing. They show you a whole bunch of dimensions in it. Don't necessarily assume that they're the exact right position. Don't necessarily assume that they are on, say, for the right views, for example. We need to follow a set of standards in terms of placing dimensions. These standards are covered by the ASME standard Y14-0.5-2009, and we'll talk about what the standard represents in this presentation. So we're going to be learning how to dimension something, and one of the key things about this is we need to understand what our goal is when we start. So when you think about dimensioning, what is the purpose of them, and what are they supposed to accomplish? So think about that for a section. Well, dimensions should be clear, right? So you should be relatively straightforward to read. They should be concise, meaning you don't want multiple dimensions showing the same thing, but they do need to include everything needed to manufacture and inspect the part. That's the kind of challenging part, particularly for someone just coming into CAD. So we're going to spend some time on that and realize that's going to be a work in progress. You're going to do the best you can, but that really takes draftspersons a while to begin to understand really all the dimensions you need. So we'll be working on that, but keep in mind it is one of the more challenging aspects of dimensioning. Why it's so challenging is because you need to have a certain amount of knowledge about it. Obviously, we're going to talk a lot about the dimensions appearance, but you also need to know in terms of how you handle features, and of course you need to know the various rules associated with it. So we'll work our way through that, and a lot here. This is going to be a lengthy presentation, and do the best you can with managing all of this new information. As we learned so far, in drafting, we use mostly lines to represent things, and that's going to be true when we deal with dimensioning as well. Turns out we have three main types of dimensioning lines used. We have dimension lines. That's the actual one that has the number in it that shows you the length of dimension. We have extension lines. That's the part of the dimension that pulls the dimension off the part. We never want a dimension actually on a part, so the dimensions are going to be outside of it. To get to that, we need those extension lines. A lot of parts or features use leaders. So for example, holes use leaders, radii use leaders, any type of feature uses leaders. That's just an arrowhead being, again, pulled off the part. And in terms of these, all three of these are going to have the same thickness, so they're going to be relatively thin. And we want to make sure they're definitely thinner than visible lines, right? And in AutoCAD, we'll do that by changing the line weight. When you're representing it in other drafting measures, you got to use a way to show the dimensions are thinner and lighter than visible lines. So here's your dimension line. It's this part of the dimension right here, right? You're going to have arrowheads on each end. By the way, there's many, many different styles of arrowheads you can use. These are kind of the standard ones. We're also going to have the size of the object, right? So this is 30 units, very likely 30 millimeters. And then, of course, the lines themselves are known as the dimension line, right? And usually the feature is in a break in the dimension line itself. This is your extension line, and to make sure you know that it's a dimension and not the part, there's going to be a visible gap between the extension line and the part. Now, dimension lines should be continuous, right? You shouldn't start and stop them. The only gap should be where we put in the feature, right? So the feature size should go in there, but the rest of this should be a continuous line. Now, extension lines are going to extend from whatever feature you're coming from, right? So you're coming off the side of this, and as I said, there's going to be a gap here. You'll also notice there's a small extension on the other side. When you're hand drawing this, you're going to have to do that yourself. This is something that AutoCAD actually does for you when we're doing it. So you set these dimensions for how much you want to extend, how much of a gap you want, and then while you're dimensioning in AutoCAD, they create those automatically. So here's our leader line. Leaders are these straight lines, right, with either an arrowhead. If it's pointing at an object, it may go to a dot or just to a feature, depending on what it's actually showing. It has what's referred to as a landing. That's that little flat part here. And then it has whatever the node is. So for example, this corner has a radius of 2. This feature is a medium knurl. Knurling is that crisscross pattern you see sometimes on things you're trying to spin. So in terms of the termination where the leader line ends, if it's actually touching a feature, which is usually on the outline of the object, it's going to end with an arrow, right? That arrowhead may point to, say, the side of a circle, or in this case, the side of a radius of 2. And if the leader actually goes to a feature inside the part or inside the outline of the part, we'll see it often terminate with either a dot or just nothing, right? There's no reason necessarily to do it. Just this might make it a little bit clearer to show where it actually terminates. That's a choice that the draftsperson can make. And as I said, a lot of this is all set up in AutoCAD for you. It's a setting within AutoCAD that you can control what the end of your leader is going to look like. So oftentimes you have multiple leaders on an object, and you want to make sure it's clear what they're associated with. So one thing to avoid is crossing leaders, right? So you have multiple leaders, make sure that they don't cross each other. You don't want very long leaders. You don't want them to extend a long distance off the part. That makes it kind of challenging to follow. You also want to make sure they don't get confused with other dimensions. So you want to avoid any leaders that are parallel to dimension lines, extension lines, or section lines. This is usually done, by the way, by using an angle on the leader. Right, dimension lines tend to be horizontal and vertical, so an angled leader line really jumps out because it's not. The other thing is you want to make sure that the angle is large enough so you can actually see it. So a small angle, anything less than say 30 degrees between the leader and the terminating surface you want to avoid. So now, obviously, sometimes it's challenging to do all of these simultaneously. Some of these rules can be bent along the way, but if you are careful about where you place your leaders, then you should be able to avoid most of these problems. In terms of dimensions, it's what you're trying to show the size of. So we'll have two main types of size dimensions. Those are linear dimensions. They tell you how long something is or how far something is in terms of position. We also have angular dimensions, and then we'll have a variety of notes. Notes are kind of a catch-all for all the other things that aren't distances and angles. Now, linear distances are almost always going to be done horizontally and vertically, but they don't have to be. And depending on the part itself and if some of the issues are particularly important, let's say, for example, you had a slot in a part that was at an angle, the length of that slot might be very important. And in that case, you may want to have the linear dimension actually aligned with the feature, right? So while most of them will be horizontally and vertical, there are situations where aligned, non-horizontal, non-vertical linear distances are also used. Angles are used to show an angle, right? Pretty straightforward. Usually this is between two surfaces. Say, for example, you have to cut a part at, say, 30 degrees. You need to show that angle, but they also could be used to show position. For example, if you're going to have a series of holes going around a circular object, you might want to show the angle of those holes. And keep in mind, it can be between surfaces. It also can be between features on the part. So anytime you want to show, though, an angle, usually done in degrees, then you're going to use the angular dimension. The last type of dimension we're going to talk about is notes. Notes are used to dimension various features. So, for example, you have a hole or a cylinder, you might want to suit the diameter. If you have a rounded off corner, use a radii. A squared off corner would be a chamfer. Things like threads, the knurl we saw earlier, those are all done by using notes, note dimensions. It turns out there's two different methods. We'll discuss a little bit later on. When you draw a dimension, it's all about clarity. So we want to make sure we know exactly where the dimension ends. We do that by showing it with arrowheads. Right? Arrowheads can be drawn in a couple of different methods. It all depends on how much space you have. So if you have plenty of space, the preferred method is that the arrowheads are inside the extension lines. But when we get starting to get squeezed down, right, that may not be possible to have the arrowheads and the dimension inside the extension lines. And this is one method, right? We can have the arrowheads inside, but the dimension is pulled outside. Or we can do this setup here where we limit it. Again, we're limited. Now the arrowheads are on the outside, but the dimension's still on the inside, right? In general, obviously, this is the preferred method with the arrowheads inside, arrowheads and dimension inside. And either of these depend on what other dimensions are there and how much room you have. Both of them are fine. Now you're going to be using lettering to show dimensions and other notes. So when you're actually hand drawing these, you really need to be careful. The lettering should be legible, relatively easy to read. We practice lettering early on in the semester when we're doing our sketches. Make sure you use that same style of lettering. All dimensions are actually done in uppercase letters. Right, so unless there's some reason for lowercase lettering to be used, for a part-specific thing, uppercase is the standard. And in terms of the height of them, in terms of the height, when you print it out, the small size they should be is 1/8 of an inch, which is 0.12 inches. Same thing true in metric, about the same size, 3 millimeters. That's the minimum lettering height. That's the size when you actually print it out or create your PDF. It should be that size. Now, in addition to lettering, we're going to use a variety of different symbols. Symbols are sort of abbreviated way to show a chunk of text. So the whole idea is to, one, make the dimension a little bit smaller, more efficient, but it also eliminates language in translation. So a dimension symbol means the same thing in English, in French, in Portuguese, etc. So there's no need to go through and actually translate the language. Now, in terms of symbols, keep in mind that the symbols that are used throughout the world are pretty standardized, but we're going to cover the ones used in the United States. But keep in mind, a lot of things that are manufactured in the United States are actually made out of subassemblies outside, etc. So you got to be comfortable with using international symbols. Here's the standard dimensioning symbols we'll use. The ones in bold are the more common ones. So we have diameter, right? That's going to be used to show holes, cylinders. Spherical diameter, pretty rare, but if you're doing a sphere, I show the diameter. This is how you do that. You have your radius, right? Radius is used when you don't have a full circle. We'll show you examples of that. Of course, spherical radius, again, if you have a sphere. We also have what is referred to as reference dimensions. Reference dimensions are just dimensions that are there to show you some information, and they're going to be shown in parentheses. Any dimension shown in parentheses is a reference dimension and should not be used for actually manufacturing the part. We talked a little bit about these counterbores and spot faces. This is a type of fastener mounting technique. This is the countersink symbol. Counterbore symbols and countersinks we'll talk about in more detail a little bit later. And then one way to, again, make dimensioning more efficient is to use this X symbol. And what it means is, so for example, let's say you have 4 holes, they're all half an inch diameter. You can say diameter 1/2, and then you can have your 4 times. And the 4 times tells you that there are 4 holes that have that same diameter. Right, so that's an efficient way. So you don't have to put a dimension on every single one of the every single one of the features if they're going to be the same. Right, that's a more efficient technique in terms of dimensioning. If a hole doesn't go all the way through a part, you have to show its depth. There's our depth symbol. Right, it's just a flat with the arrow pointing down, so you show how deep it is. And then there's a variety of these that we'll probably not use too often, but you should be aware of them. If a dimension's underlined, it means the dimension is not to scale. This used to happen a lot in the old days when you had pencil and paper drawings and you had to make a change. Not very common anymore in AutoCAD. It's very easy to adjust the size and shape of an object, but it still could turn out. If you have a square shape, right, you can use the square symbol. If you have an arc, right, a part of a circle, you can show the arc length. And then if you have some unique objects like conical taper, a slope surface, or you're trying to show that something is symmetric, you can use these symbols. But again, the ones that probably is the most common one on here is going to be this depth symbol. So when we dimension features, this first example is the difference between using a diameter or a radius. Right? If it's a full circle, then you should be dimensioning it with a diameter symbol. But if it's an arc, meaning only a portion of the circle, then you should be using a radius symbol. Right? So here we go. Here's a hole. Right? A hole is shown with a diameter symbol. Right? So use your diameter symbol, and this is the diameter is 10. Right? Here's a radius. Right? It only goes halfway around. Then we're going to use the radius symbol. Now, if it's a solid part, meaning it's a cylinder that's sort of sticking out, you actually dimension in what's referred to as the square view. This is referred to as the round view. So in the square view, we do our solid, and again, we use our diameter symbol because it's a full cylinder. Right? So a hole is going to be done in the round view. A solid part is going to be done in the square view. But both use the diameter symbol. Another common feature that you'll be dimensioning are holes. Right? Holes are shown with a diameter symbol. Right? Keep in mind, if you only have a diameter symbol on a hole, it's what's referred to as a through hole. Through hole means it goes all the way through the part. But if a hole does not go all the way through the part, like for in this example, you're going to see it's going to go to a point. Right? Holes are usually done with drills, so they actually have a point on the end of them, and then they're going to show you the depth. Right? One key thing about the depth is, if you notice here, the depth is to the bottom of the full size of the hole. It does not include the point, right? Because what you're actually measuring is you're kind of measuring the effective depth, and if you were to insert something into that, it would only go down to this point right here. So that's what the depth represents, and there's our depth symbol used in the dimension. Now, you don't need to put a depth on a through hole, right? If the hole goes all the way through the part, you can put through on it sometimes if they think there might be some confusion, but that's only if it's not clear. In general, all you really need to do is just put the diameter symbol on. The fact that the hole goes all the way through is going to be shown in one of the side views, right? So it should be relatively clear. But if you think there's any confusion, you can also add this following term through on a hole to ensure people know that it's a through hole. Now, this is one of the more confusing things. If you don't get this right away, that's okay, but you need to understand one of the things about any time you have a rounded feature is you have to know where the center of that feature is, right? Now, sometimes it's obvious and you don't need a center mark. So for example, on this first one, it says radius 30. It's pretty obvious, since this is a 90-degree curve, that the center of this is just 30 in, right? 30 in here from the right and 30 down from the top, right? Or 30 left from here. Now, if it's not a 90-degree curve, or 180 degree works as well, an odd curve like this, you don't know exactly where it's going to be located. So in this case here, we need a center mark, and we need to show where that center mark is. It's 50 up. Now, you don't need a dimension on this side, because you'll notice this comes in nice and tangentially, and so we know that the distance from this center mark to this edge is the same as the radius of 30. Now, in this case here, where you don't have someone coming into a horizontal or a vertical line, you need to show both the vertical height and the horizontal distance here to position this center mark. Right, so you don't always have to dimension center marks, but when they're not obvious from the feature, you do. And then in that case, not only do you need the radius symbol, but you also have to locate the center of the radius. So I mentioned there's our spherical diameter or spherical radius. They're used pretty similar to our diameter and our radius symbol, but of course it would be if you have a sphere, right? So in this case here, if you have a partial, I should say a full sphere, right? It's completely round. You can use the spherical diameter. In this case, it's 40 units. If it's a portion of a sphere, then you use the spherical radius symbol here, right? Obviously, this is going to come up relatively rarely, but there's a few cases where this will, and you need to recognize what that S means associated with the diameter and the radius symbol.